name's Sabina Hollerman, and in this video we'll be going over subatomic structures and particles. So throughout this video we're going to talk about protons, neutrons, and electrons. And my group partners over here will go in depth with each of those subatomic particles.
Hi, I'm Aspen Jones, and the first subatomic particle we're going to be looking at is the proton, whose symbol is the P with a little superscript plus. And that superscript plus is there because it has a positive +1 charge. And so protons are found in the nucleus of the atom, and along with the neutrons, which are also in the nucleus. And protons help contribute to the mass of the atom, and the number of protons actually determines what element the atom is. So if you were to somehow remove or add a proton, it would completely change the identity of the atom. So also they determine the atomic number of the element.
So hello, I'm JDL Davila Velasquez, and I'll be talking about the neutrons. So the neutrons in our model here are going to be pictured in a green, and the symbol is going to be an N with a 0 as a superscript. So they have a neutral charge, and they are also located within the nucleus. So in order to actually obtain the number of neutrons, you have to subtract the atomic number from the atomic mass. And unlike the proton, this number can be adjusted and you still have the same element, but you would create an isotope. If you add too many neutrons to an atom, it is eventually going to be radioactive. And then two quick fun facts. James Chadwick discovered the neutron in 1932, so it's actually less than 100 years old since it was discovered. And neutrons are slightly heavier than protons, making it the heaviest of the subatomic particles.
Hi, I'm Macy Gilman, and I'll be talking about the electron. So the electron has a symbol E with a subscript negative particle, and so they are the negatively charged subatomic particles of the atom, and so they orbit the nucleus. They are not inside the nucleus. That's where they're different from the protons and the neutrons. And so they kind of orbit in this electron cloud. So these rings here, they're not actually real. This is just for drawing purposes. And so they have distinct energy levels of the shells. So the first one can only hold 2 electrons, and then as you grow in shells, you can hold more electrons, and this helps distinct what electron configurations they have, like s orbitals, p orbitals, d orbitals, but that's a whole another topic. And so yes, and just repeating, they have higher energy levels the further out you get. So on the periodic table, if you have an s orbital electron versus a d orbital electron, they're gonna have way more shells than just these two. So actually this is only lithium, so this only has 3 electrons, so it'd be an s orbital electron configuration, but you would draw that completely different than this. And so they also influence chemical reactions, so they can be shared or exchanged depending on what other elements they're combined with. And so when you either share or exchange these, they can create molecules, which create several different chemical reactions, and there's millions out there that you can make. And so that's just my quick post on my electrons.
And so now we're just going to go over some examples of the different instances electrons, protons, and neutrons can change in an atom. And so in these 2 instances, it would be electrons are changing, and so it's like I previously said, you can have more or less than normal, and that just changes the charge on the atom itself. So in this first instance, we've lost an electron, so this would make it a lithium plus atom because the protons and the neutrons aren't changing. So it would still be lithium, just without an electron that it's normally supposed to have. And then down here, it's kind of the same thing but opposite. It's just we're adding an electron, so it's still lithium, but instead of 3 electrons, we now have 4. So it's more electrons than protons, so it has a negative charge.
All right, so kind of showing one of the changes that can happen to the atom. In this case, we added 1 more neutron to this. So instead of having 3, we have 4 neutrons now. So this would therefore be an isotope of lithium. The more neutrons that we add, the more unstable it becomes, and that could therefore lead to radioactive isotope, which would be short-lived. But in this case, kind of just showing here exactly, there's 4 neutrons here rather than the original 3 that were on the normal feet.
Hi, so in the event of a proton changing, which doesn't happen, it would completely change the identity of the element. So for example, in this one it has 3 protons, which is lithium, but if it were to lose a proton, it would turn into helium. So that's not exactly something that would happen, but it does, if it were to, it would change the atomic number as well as the atomic mass and the identity of the element itself.
All right, so overall we've covered the different identities of the subatomic particles. We have our positive protons, neutral neutrons, and our negative electrons. And we've discussed their placement in the atom as well as what happens when they change. Like our electrons changes it and turns it into an ion, whether it's a cation or an anion, positive or negative. The neutron changes its atomic mass, and it also can become radioactive and unstable if too many neutrons are added. Then of course we have our proton, which if you change it, that's just alchemy, just changes the entire identity, lead to gold, that whole situation. So thank you so much for watching. That's all we have for you today.